Man, the whole mix of like ads on Twitch and like not being able to play music now. I'm actually thinking of moving to YouTube. At least trying a few YouTube streams. Alright, this is something we haven't done for a very long time. This is something I did for around 3 months on the channel. Every day I would spend an hour or two and I would create a real-time animation. Hold on, actually. I think I have it linked right here. Yeah, Renderings YouTube. So a few of these I did into 4K rendering animations. Man, I hate YouTube as well, though. That's the issue. It doesn't let you... Oh my god. There we go. The way it just like goes to the next video. This one was definitely too fast, looking back at it. But it's like a cloud orbs. Most of these are ray traced. Man, YouTube actually sucks so bad. Like the UI of YouTube is just so hard to navigate. So clunky compared to other things. If only hosting videos wasn't so expensive. I liked this one, Firefly Effect. I need to get a something that turns off YouTube suggestions on the side of the video. Some of these are super basic, but that's kind of the thing of doing it in an hour. I also had some pretty bad noise on a lot of these. Oh, this one was really good. I liked this one. And the coolest part, oh no, it didn't loop. This was my background for a while. The rendering of this. It's really nice though to render these in 4K and use them as a background brew. Did this for St. Patrick's Day, I think. Oh, this one is so simple, but I loved it. It's just reflecting rays off a bunch of perfect mirrors. Alright, anyways, set this render back up. This is this program I made. You can get this off my website. It's actually linked down in my Twitch. There's a video of it on my YouTube as well, if you're there. This program renders GLSL shaders. It's console based, so I don't know, some people might not like that, but it works on Windows and Linux. And one of the key things is it has the ability to, so wait, here's my shader. I have it loaded right now, right? Oh, frame delays. Hold on, okay. I gotta change up the code. Anyways, it has a lot of features, I think, compared to most shader viewers. The key thing is it lets you capture images and videos. You can capture images or frames as PNGs and videos as MP4s and WebM with FFmpeg. It supports transparent videos, so if you're doing animations or things for videos, it's very nice. I just loaded up the wrong thing. Alright. What did I set the delay to? 10? Okay, here we go. So, it has a lot of options. Like this delay option lets you tell it to not render frames for, like, not output frames for 10 frames because it's like building up frames for path tracing. So that basically lets you do, like, tell it to take 1,000 samples, and that lets you do progressive rendering really easy. Did you code this from scratch? This was actually coded on stream like 2 years ago. It also uses my C game engine, Strand engine. But yeah, the key thing is being able to take this and using the capture command. If we want to set the frame rate to 60, and let's say we want to capture 4 seconds, then you would do 60 times 4, which is 240. So you do capture 240 frames, and you'll see here it's actually rendering them out. And then done capturing, go into the folder. We've got our video.mp4 here. And there you can see it rendered it out into an MP4. And it's really easy when you're coding the animations to make them perfectly looping like this, which is something I really like to do. That's what we're going to do for, I'm going to create another animation just with cubes today, but it should still be pretty good. And I'm also going to do a much nicer quality rendering than this. The longer I let it sit and render out more frames and more paths and rays, the higher resolution it gets. Hold on, so this is the rendering I did last night, and I put this out on Twitter. You can see it's pretty much smooth. Actually, most of the issues now are coming from like compression artifacts. You can kind of see, but yeah, overall I think it's really good. So we're gonna do another one of these this morning because it's so fun and easy to do these. And like, I think the reason I just stopped doing them was I just stopped being like inspired. Like I actually just didn't really have ideas for like any of these animations or structures, or like, I guess I was focused more on other stuff. Hold on, I just need to change some stuff around. So the way I do this is, because it's a path tracing shader, it has two stages. It builds up the frames first. This is the main shader that does the actual path tracing and builds up the frames. And then there's just this dinky little display shader that all it does is it outputs the frames by dividing by the number of frames that have been added up, and then it does gamma correct, because gamma correct is key for getting it realistic. The path tracing shader here, this is hard to explain, but it's actually not too much code. Start with a ray position and ray direction. We have our geometry defined as a distance function, so we sample the distance function at the position, check if the distance is smaller than some epsilon, that's our threshold to the surface. If it is within the threshold, then we've hit a surface. This is doing ray marking. If it doesn't hit the surface, it steps forward, marking forward. So then we have a hit, samples the normal and the material at the position. These are the normal. It's done by taking derivatives of the distance function, the geometry distance function. And then the material is just a function you code yourself. It returns material color, roughness, and emission. You can simulate materials like glossy or plastic. So this actually isn't a full material system. This doesn't have Fresnel, like the whole thing of like index of reflection. It doesn't have like glossiness built in, but you can actually simulate all of this in the path tracing system by dithering between two materials. A glossy material is actually a highly reflective material, the gloss on the outside, while having a more diffuse or some other material on the inside. So you can actually simulate that by dithering between the gloss material and whatever other material. And then there's a background function that returns the color of the background at a position and direction. And all of those define the procedural scene. And then we ray trace it, like down here, sample the material, get the tangent and binormal, also called upright from the normal. We add the lighting and multiply the current ray color by the material color. Hold on, actually, I'm looking at this. Is this right? Mat 0 times this. Or would it be C times? I'm actually not sure if this is right. I think... I'm just thinking about it because I'm multiplying by the color down here. So if I multiply by the color up here, it's actually multiplying by the color twice. So I think just adding the emission to the light does the same thing, because then it's going to get multiplied by the color down there. Yeah, because then if it hits the same material twice, it's just going to keep multiplying the color. Okay. Alright. Actually, no. That doesn't necessarily work, because then if different colors have different emissions, like if there was like 10 times more green emission than red, then the red would get multiplied out. Yeah, hold on. I should actually think of names for these besides just C and L. Yeah, Yeah, I actually think this can just be a single value, except for right here. I guess I'll compute the final background plus compute final lighting. Excuse me. Alright, everything seems good here. Yeah. So I was explaining the ray tracing before I got sidetracked. Figured out something was I actually programmed something a little bit wrong there. I actually wouldn't have had that too bad of an effect. It would have made the emission colors more saturated. Yeah, more saturated, or less saturated. Yeah, more saturated. Anyways, once we add the emission ray color, we back the ray up a little bit, because we do that after we've sampled the normal and material in the surface. And then, now that we have the material and the tangent and binormal and all that, we reflect the ray. But we don't just reflect the ray, because that would give a perfect mirrored reflection. To simulate surface roughness, it generates a random 2D vector, not normalized or anything, based off the frame and the ray position. From that, I think these are called Cartesian coordinates. Uniform points on a sphere basically generates this CT is like the Y. You can almost think of it as like the Y, the up or down on a sphere. And then from that gives us like the ratio. Like, I don't know if you think about it, but like if after the Y you have the part that spins around. Hold on, let me look up. I'm pretty sure these are Cartesian coordinates. And this will probably explain what I'm trying to explain way better. No. I'm an idiot, I think. What am I thinking of? No. It basically seems like Euclidean geometry, unless I'm stupid. Spherical coordinates. Is it? It's not polar coordinates, is it? Well, I think this is actually just a polar coordinate system. I don't know. It's not storing it as angles, though. We store the values as... Man, this is really hard math to explain. This is like this is such an interesting thing for me, because I don't even, like, my brain doesn't understand it how Wikipedia explains it as this generalized English. Like, reading the actual math is seriously just like the best way. I'm trying to think how to explain it like that. So our mat1.x is the roughness. So then it takes our random.x and it scales it with pow based off that roughness. So if you know how pow works, the smaller roughness gets, the bigger rand.x will get put up at smaller values. Actually, I'll plot this out. Hold on. I just typed in my own website wrong. Feels bad, man. Alright, so like say our roughness is 0.5. We can see our power curve here, so when roughness is 1, it's actually equivalent. This actually, so just to give you back to the ray tracing, when the roughness is 1 and this random.x is actually linear, this is equivalent to a uniform cosine sampler, uniform hemisphere cosine sampling. So what ends up happening is that as you decrease the roughness and make it sharper, it will lift up these smaller values of rand until it's this system. Actually, another thing I should mention, you can't actually have 0 roughness. It actually breaks because you can't do POW 0. It does. Actually, I'm not sure if you can do that in the GLSL spec. I think it might cause rand, or nan. Anyways, you lower the roughness and it makes this spike up and nearly almost always be 1. So this, I actually was explaining this wrong. This isn't like the Y. This is like So you go to the next part and you see square root 1 minus this CT times CT. So imagine roughness is 0, it'll be 1, 1 minus 1, this will be 0. So then we go to PT. This is actually our spinning around our yaw. This is, so it takes the rand y and it does pi times 2, which spins it all the way around. So like I was saying, if it's a sphere, this is like the actual majority of the direction is the 2D x and z. If we go now to look at how it actually mixes together, so what this is actually doing is this is generating spherical interpolation values to interpolate between the normal, the up and the right, the tangent and the binormal, and do proper interpolation. So yeah, you can actually see here, this will now generate a random surface direction that is offset a certain amount based off roughness here. Like this basically will generate random surface, microsurface bumps to simulate the microsurface roughness. So going back to explaining the math, do you imagine this is 1? This will come out to 0 because 1 minus 1 is 0. So then you can look at this. The CT, I was actually right explaining this as like the spherical Y. I can actually draw this out, I think. I want to practice doing like visualizations and stuff like this and drawing them out, so this is probably going to be pretty bad, but I'm trying to get better at doing these. So this is like the side view of the sphere. This is the top view. So this is CT and ST. Oh wait, no, this is CT. let's not use Calibri. So this, the amount going up, this is what CT is. So then you can imagine this ST is like inverse of CT. Wait, what? Hold on. Alright, so that explains the first part of the sphere, the going up and down. Then, this PT, this is the angle. Oh my god, this is actually polar coordinates. I just realized I'm a goddamn idiot. Doing sine and cosine here with PT, this is absolutely polar coordinates. Alright, this is good though. So this is actually this is a really important thing of math. This is polar coordinate system. Dude, Wikipedia is just so hard to understand. I don't know if that's just me, but it's like Wikipedia is brutal. Okay, so then once you have CT, this gives us how much, like how much magnitude our sphere or whatever has, like how high on here. And the other thing to realize is that, and I actually messed up drawing this. This actually goes up like here. Like CT actually only goes up past here because it doesn't go negative. Like down here past the halfway point would be negative, and if you see our CT value here, it's always positive. So what that does is that generates a hemisphere, generates like the Y value for our hemisphere, or the vertical angle. So then our PT is the amount going around. So I think describing these as yaw and pitch is actually not a bad way of doing this. So we basically generate a random yaw and pitch, but if you imagine it, as you get higher, so this right here would be like this part going around here. And if you look here, the distance between these two sides here gets smaller as you go farther up the sphere. So by the time you're at the top here, the size of this is actually way smaller than in the middle. So this is actually what ST, the inverse of CT, is doing, is when CT is small, it's 0, so 1 minus 0 is 1. The size of this is 1. This is actually, ST is actually computing the size of this. I'm so confused why my drawing just like breaks all of a sudden in paint.net. It just doesn't draw a line sometimes. Is size radius of I don't know what to call these. What, like, I should probably have read that polar coordinate system Wikipedia, but anyways, that's how we generate a random surface position, is we generate a random positive pitch and yaw, and that is scaled based off the roughness. So this is actually super key here, because there's different ways that you can generate the random this is the BRDF right here, actually. There's a lot of different ways you can generate the random distribution of like these random values to roughness, but the like reality is, or like, man, it's so complicated. As far as I'm aware, this is realistic from what I've seen. I based this off of Veach's. Let me see if I can actually bring this up. I might have just spelt that name wrong. Yeah, I don't think the paper's public. Oh, never mind. Here we go. I think it's right here. Maybe that. Oh, there's so many parts of this paper. This stuff's so good, though. Like, oh man, there's so much good information on the internet. It's crazy. It's like a gold mine. Alright. Anyways, I've kind of tried to explain this stuff long enough. I think at this point I'm just going to make an animation. I'll just show the actual process of creating the distance functions and all that. I also need to, I realized I need to update this. Added a fix for when normalize returns not a number. Alright, what am I going to name this one from yesterday? Connecting cubes or something. Abs animated disconnect. Mirrored disconnecting cubes. Just super literal. Because I don't actually need a name for it, just something that makes it different. Alright, so let's begin exactly where we left off with that last one. We're going to begin with the red cubes animation. My gedit window just got way bigger than my actual monitor. Alright, I'm going to set this up so that we've got the animation on one side. Very nice. Very nice. It all fits together. I gotta get more water. Alright, I think I should do something different, at least to begin. I just realized I'm calling this a sphere structure when it's cubes. Hey, Namori. All right, let's at least do something to begin. I'll make the background completely dark. And then we will make the cubes emissive. Nice. Okay. So, I actually have an idea of the animation I'm trying to do. I think I'm going to need 2 cubes for this. So I'm just going to start with a cube to begin. And I think I am going to use a background. I might change it up, but the background does just give decent lighting to begin. Alright, and I don't want the camera rotating, but I am going to have the cube rotate, I think. Actually, I'm going to be trying to make a looping animation, so I really got to take that into the design. I might just try and do 2 cubes, like Matryoshka dolls, to begin, where like one cube pops out of the top of the other cube as it's zooming in, and then goes out like quick enough that it isn't noticed. Yeah, so I think to begin, I'm gonna try just like locking the camera position back a little bit, and then the animation is gonna all be done in the distance function with the cube here. I am going to want to repeat time after a certain period, so I'm going to do mod time. Oh my god, I just realized. Oh, never mind. Man, for some reason you can't see my mouse cursor when it's on gedit. It's like probably one of the worst things ever for streaming, but I have no idea how to fix that. So I think I'm just going to have the sphere expand over time and move downwards. I think I just called that a sphere. Oh, yeah, interesting. So having it expand at the same rate that it moves down, it never actually moves the horizontal part. Yeah, this is going to be key in doing the animation. So I think I'm going to do that. And then I should be able to actually have it sort of like go, like start actually moving downwards while I have another cube begin to go out the top of that. So I'm just going to switch this to white just to make it, oh wait, that actually makes it way too hard to see. Okay, I'll make it gray and I'll make it rough. Yeah, I think I'm gonna start doing another cube now. I'm wondering if I should do that, like, thinking of doing this with a for loop. Because then I don't write the cube code twice, but then if I need to have, like, I might not be able to do like the time synchronization just with C. I might need like custom variables for each. I don't know. Let's try it. I actually think I'm going to need to do mod here and not down here. Yeah, so unless the other one starts moving down, the next one isn't going to appear. So I think if st smaller than 5, then plus equal, so maybe it comes down from, this will make it come down from above, I think. Let's see. Oh no. Come up from below. Okay, this might actually work. Wait, why is the one down there? What happens when they pass each other? Wait. It went all black because the cube just filled the screen. Damn. Oh, it's because I'm not doing this. What's gonna happen to the bottom one? Is it gonna pop back up top? Yeah. Okay, so that is looping. Alright, that kind of works, but it's not looping. Excuse me. Now it's too far down. Oh my god, it works. It works. Now I just gotta make it rotating. Let me actually do a nice, let me up the frame rate on this. Still kind of going too slow. Alright, that's nice. Now let's see if I can get this rotating. Because that would add like a nice more effect. If I get one of these to rotate as it goes down. So let me think, where would I do that? Try doing YZ. Oh, we actually have a bit of a ray marking artifact there. It's actually nice that we caught that. Can focus on fixing that now. I have a pretty solid idea of how to fix it. Still a bit of it. Like recursion animation? Yeah, that's kind of what I'm going for. Yeah, there's still a little bit right there. I almost wonder if that is from the normal right here itself. my god, it is. That fixed it. So I actually think I want to sample the material. Okay, so I want to sample the material before we do that back step. Alright, now let's see if we can get this rotation to match up and not have that clipping. Oh, that's kind of cool. So I was talking about adding a gloss to materials before. Here, I'll add a gloss to this, to at least make the material more interesting. So it's going to be a kind of bright gloss, reflective, with a tiny bit of roughness. Otherwise, I think I'm going to make it like brown. And it's actually hard to see what the gloss is even doing without a much higher sample count, making it clearer. I'm actually kind of curious. I want to do I think there's still some artifacts here from the normals. We're backing up on the ray direction. It's hard to tell though, it might just be noise artifacts, but I swear I'm seeing some stuff here. Yeah, there's definitely some like lines right here. So I actually have a pretty solid idea of how to fix this, but it's a little bit more expensive. Wait, what the hell? I just realized I rewrote this code. And did I rewrite it in here instead of the code I'm actually writing? Oh my god, I rewrote it here. Classic. Okay. Do you not use your GPU for encoding Twitch? No, I don't. I've seen worse quality in NV encoder. stream very stable when you use this shader. Yeah. That's funny because NVENC is actually supposed to be more stable because the whole idea is supposed to be it doesn't waste time sending data between the GPU and CPU. If only it actually worked like that. When you use 100% GPU, it's dead. Oh yeah. Oh yeah, I figured out how I'm gonna write that autoencoder blog post. So I'm gonna go into JS Fiddle and I'm gonna try and compress everything I did the other day into like 100 lines of JavaScript. I'm not gonna use like a class or anything for anything. I'm literally just gonna program it all with arrays. And I should be able to get it into around 100 lines, and that way I can do this thing where it's like, hey, check out this minimal 100-line autoencoder. And then in the blog post, it like starts with that and explaining that code, but then it uses like the actual encoder little app I made that shows the actual encoding kernels and like what patterns it uses to encode. So that way I can do both of doing like my more detailed app that lets you view like the internals while also doing a tiny little minimal example that's easier to understand for people. Alright, it's really hard to see, but there's like lines right here. And it's due to this sampling. Something about it, I think. Wait a minute. Wait a minute. If I remember correctly, this only happens, I think I can fix this by doing a full derivative sample. Right now I'm just sampling the axis offsets, but if I sample like offset the center on both axes, it should work. Let's try this, because if that does, then that's a really easy and nice solution. I think I just locked my cat. I think I locked my cat in my room as well. It's a really bad move. But it's all good if my cat doesn't want to leave. Alright, so now we add an extra, this will add a tiny performance cost, but if it fixes and improves quality, it's all worth it in my opinion. So I was talking the other day about how I'm going to go back and do some Unity dev, just because it's like, realistically there's so many tools there for 3D development and all that stuff, especially VR. And one of the things I really want to try to get working is some kind of like ray tracing in VR, because like everyone's hyped about, or I just feel like custom shaders can just be so much cooler in VR. It's obviously way harder to integrate. I feel like when you get that, it's like, or if you can get it working. Oh, interesting. That gave a Huh. it works now on one side, and then the other side it has those same errors as before. Wait, what? That's YXC, YZX. Maybe I need to reduce the epsilon. Oh, that did fix it. Except for right here, these errors. So I wonder if that's just the ray not being backed up enough. No, that didn't do anything. There's still those lines. I wonder if that is just the epsilon. It actually could just be the epsilon precision. Okay, let's try increasing our epsilon, or decreasing it, making it higher quality. They're moving in like waves across it. I don't think that's the epsilon. This is like classic ray marking. Tiny little like precision errors. I wonder if this has something to do with the gloss. No. That's actually better. It actually shows it off. It's my noise. It's the noise algorithm. Oh, okay. That's actually awesome. That's so good. That's actually okay. It's not a bad thing if your noise is actually moving in waves in a path tracer, as long as the waves move uniformly, like as long as it's not ununiformly sampling. Alright. Alright. It's all good. So I kind of like this. This one's kind of like, I don't know, like, I don't know how to describe it actually. It's like, yeah, like a recursion. And this is zooming in. What if we get a bigger or smaller field of view? Yeah, I think the one field of view I had was still very nice. Let's try doing different rotations. Hold on, my cat does one out now. Alright, this spinning to the left and right is a lot less exciting. Oh, that is... Yes! That's a good one. That is a good one. If I can just get it zooming in kind of more, so that other one doesn't like move out of the field of view like that. What if we do the Y rotation before adding it? Hmm. Oh yeah. Hmm. If one of the really interesting things I figured out the other day is that one of my for loops is dynamic, based off a floating point value, right? And so if somewhere in my code I get not a number, it goes back to that dynamic loop. And the dynamic loop is actually based off like a random hash that's used from like a bunch of things like ray position and stuff like that. So if the not a number gets into the ray position or normal or anywhere, it goes to that dynamic loop and causes the dynamic loop to go for infinity. And then that crashes my GPU. Pro strats. Oh, whoa, this is like upside down, but it's actually not horrible. Alright, my GPU actually is lagging a bit, so I turned down the frame rate a little bit. A few days ago, I found one more shader that crashed NVIDIA GLSL compiler. I found a lot of things that crash that. It's not nice. This one's kind of nice. I still think these doing it down here is still way nicer. I want to try to get it so that this bottom one stays more oriented and doesn't slide down. I think to do that I can just limit the rotation. Interesting. It doesn't stay oriented then if the other one doesn't rotate. I think a solution could be I don't know, I'm pretty happy with it right now too, so I'm kind of just looking for some quick hacks to make it look better. Increasing field of view should make it look worse, because then you can see more of this, more of that sliding away. So then maybe decreasing field of view makes it better. No. That's actually pretty good. that just makes cubes plop in and out of existence. Not bad. That kind of looks like cubes are spawning out of more falling cubes. I don't know, I almost think I like the other one more. And then maybe doing it at like a close angle. Yeah, it still does bug me that it starts sliding down. Oh, this is like the opposite. Yeah, I actually think I like this one. Let's try and change up the lighting and stuff. Now, what if we made it with a pretty much dark background? And then we made the one cube emissive. Now, how would I do it so that the one gets more emissive than the other? I need to calculate here maybe the Y. Or I need to calculate the actual geometry. I guess as a cheap effect, let me just try doing the Y to begin. No, yeah, I'm gonna need to compute actual geometry. I actually need to check this. If smaller than d, then the emission is actually based off this c. Or actually base it off st. Here we go. Yeah. Now I'm super interested. We can't see our gloss right here. The gloss isn't showing up. Okay, I just nearly crashed my GPU. And it messed up the video encoding there too. What did I just do? I'm actually really curious. I didn't think that was going to cause not a number or something. Let me just comment this out. Pretty sure it was that caused it. And I'm just going to return the actual background. So there's the glossy material. You can see the perfect reflections. So now let's try toggling that on and off between each frame. Did that crash again? What? Dude, I'm actually having more GLSL crashes in these past few days. Like what the hell? Am I an idiot, or like how does this crash it? Like, this actually doesn't make sense. Is it something with matte 2x3? Like, I know what's crashing it, it's the infinite loop, but where is not a number being injected? And why is it only injected in this when I change this material? Like, that actually makes no sense. What? Oh my god, is it because of, wait. Maybe GLSL POW 0? Can you not pass in 0 to POW? Undefined if x smaller than 0, or if x equals 0 and y smaller than equal to 0. Oh my god, that's what it is. I think. Okay, if that isn't what it is, I'm absolutely dumbfounded. No, there we go. Okay, that seems like it fixed it. Let's... Alright. That looks like it did it. Let's try going back to the old lighting. Man, gotta love GPU crashes. Keeps you on your toes. Nice, it didn't crash. Still not as much of a glossy reflection as I would like. Maybe stop the lighting a little bit earlier. Wait a minute, what is that? Oh, it's because I didn't update. I didn't update it in the... I updated in the material without updating it here. think I need to have it interpolate much slower. Like, I can have it go down in brightness. You can't tell what's going on nearly as well. What if I actually made this backwards? What if, as it gets to the end, it actually brightens up? And then you get the lighting going away like that. The way it just snaps on right there, not a fan of that. Ah, it's because the one toggle's off. So I think, yeah, I'm not going to do any of this fancy emission or anything. I think I'm just going to do a strong directional light. Just trying out different colors. Now let me try doing the light from like a really sharp backwards angle. I just did nothing different. Oh my god, I just realized, does this make... Oh no, you have to do -1. Oh, that's kind of cool because it has to like reach up to get the sun. Oh, that's kind of nice. What if I made it like nicely attenuated? Alright, let me just try a light just going up from the bottom. The gloss actually doesn't add that nice of a material effect. Alright, let's try and do a rendering of this now. I think the lighting and everything should look decent. See if 200 frames is enough. That gives decent results. So let's see, at a frame rate of 20, the whole loop takes 4 seconds, so we need 80 frames. Oh god, that's way too fast. What is it doing? 80 frames at 20 per second. I multiplied time by 10. Of course I did. Of course I did. So the video is gonna be it spinning insanely quickly. Yeah. Gotta go fast. Okay, that should do it now. All the settings are still the same, so here we go. Now it's at the proper rate. Oh, I just realized it loops after 40. The animation actually covers double time. Beautiful. Alright, I'm pretty happy with that. Let's do a really nice rendering. Let's do. Alright, so I need to go eat breakfast. I think I'm gonna set this up to do a really nice rendering of maybe like 4K paths per pixel, raised per pixel, and then that should take like 20 minutes, and then when I'm back we will do the blog post on the autoencoder, which will just be in like 20 minutes. So yeah, I'll be back in like 20 minutes if you're interested in that autoencoder blog post. And then after that, we're gonna be going back to more game engine development. I think I'm kind of on the edge right now of whether or not I want to dive into some 3D stuff in Unity. I think I'm gonna create a little 2D game in my engine because I really enjoyed doing that for Ludum Dare, and I think that's also a really good way of like showing off and testing my engine. Alright, so yeah, see you around in like 20 minutes. If not, available on Discord or Twitter. The animation we just made today is going to be up on Twitter in like 20 minutes as a looping video, if you want to see that. And yeah, I mean, I didn't do it. What I kind of want to do is, I love making these renderings in a way that they work for like desktop backgrounds and stuff. I feel like these renderings work really nice for that. Anyways, bye bye. I hope you're doing well. Hope you have a good day, good evening, wherever you are. See you around.